Does anything cancel? You cannot cancel with the pluses inside. The y and the x don't cancel. This is actually our answer. So, again, our goal, derive everything where it's at, get y primes on one side, move everything else to the other side, GCF out, greatest common factor, out your y prime, divide it over, simplify if possible. Let's do it again. 14. Let's derive cotangent y. The derivative of cotangent is negative cosecant squared y. But don't we also have a y prime? Equals, what's the derivative of x? 1. And what's the derivative of y? Just 1 y prime, or just y prime. Okay. There's different options. Could you move this over to this side? Yeah, you can move it either way you want. I'm going to add this y over, so I get y prime minus cosecant squared y prime equals 1. Remember, you got to get y primes on one side. Now our next step is pull out a GCF of y prime. 1 minus cosecant squared y. Next, we divide by 1 minus cosecant squared y. And our final answer looks like it's 1 over 1 minus cosecant squared y. Now, technically, that is a Pythagorean identity. Okay, could we change that if we wanted to? I'm not going to deal with it right now, but you could simplify this and end up with something as a simple like value. It could simplify very nicely. Okay, I'm not going to deal with it right now, but you could simplify that even more if you deal with your Pythagorean identities. Okay, number 26. If I want to do this one right here on number 26, what we're going to do, derive everything where it's at, and then we're going to plug in 2, 1, and find, basically it's saying find the derivative at 2, 1. So derive this, you get 3x squared. Done. Derive this, you get 3y squared, but you also have a y prime. Because remember, when you derive y, it has a y prime. When you derive x, it has an x prime, which is 1. That equals, here's a product rule. Now, I'm going to put the 4 out front of the product rule. Is that okay? Derivative of x is 1. Leave y. Leave x. Derive y. And what's the derivative of 1? Can I put plus 0? Or could I just leave it? Okay. Now, our goal is to get the derivative at 2, 1. So, there's two options. Could I solve this whole thing and get y prime by itself? Yeah. Why? If I just plug x and y in, could I then solve for y prime afterwards? Can you see if I plug x and y in, I actually can get y prime easier if I wait than if I do it right now? Now, do you understand with implicits, you need your x and your y both to find the derivative? When it's explicit, didn't you just need to plug in x? But with implicits, you need to plug in both because you see x's and y's to the whole problem. So let's start plugging in. What's going to go in there? 2. What's going to go in there? 1. That's just y. So y is 1. I'll put 1 times 1 just to have it. You don't have to. And then x was 2. Does that seem a lot? Can you see how easy that is now to get y prime by itself? Now that you have all these numbers done, you just got to deal with number crunching. Again, could we have solved for y prime, got y prime by itself like we did up here? Yeah. If we were going to be plugging in multiple points, it would have been easier to get to this form first. But since we're just plugging in one single point, let's just plug it in. Okay. 2 squared is 4. 3 times 4 is 12. 1 squared is 1. 3 times 1, so that's 3 y prime. We have a 4 outside. That's 1. That's 2y prime. Okay. We're going to get y prime by itself, so the first thing would probably be to distribute this 4. And to get y prime by itself, it doesn't matter what side you move it to. I'm just going to move the 8y prime over this way and minus the 12 over this way. So that's gone and that's gone. It looks like I have negative 5y prime equals negative 8. So my answer is going to be y prime equals, divide both sides by negative 5, I get 8/5. What does that mean? If you were to graph this graph, which would be some actually non-function, and you plugged at 0.21 of the graph, your slope would be 8/5, or be 8/5. That would be the rate at that point.